Hi everyone. Today I am going to explain motional EMF. This is very important concept for JEE mains as well as advanced and also for board exams. Now I am going to explain the motional EMF. What is meant by EMF? EMF is nothing but a electromagnetic force. According to the Faraday's laws of electromagnetic induction, whenever the magnetic flux linked with the coil changes, an EMF will induce in that coil. Suppose if I consider a uniform rod of length L which is moving with a velocity V, constant velocity V, in the uniform magnetic field B, which is acting into the plane of the board. Here, as the current carrying conductor is moving in the magnetic field with a constant velocity V, what will be the EMF induced in that coil? Will that EMF drive the current in the conductor or not? All this we have to find. For that, I am going to connect a U-shaped conductor to this arrangement, so that here we have formed a loop PQRS. As the conductor is moving along the x-axis, the number of flux linked with this coil PQRS are going to change. Let us assume the position of conductor PQ from R is x, dx. It is a conducting material, it is having some free electrons. As this rod moves that side, the induced EMF at this point E is equals to d phi by dt. This can be written as minus d by dt of flux linked with the coil. The flux linked with this coil PQRS will be, the formula flux is B dot A. B is the magnetic field, which is a vector quantity. Area is also a vector. Area of this coil can be written as area A is equals to length of the coil into its width x, Lx. Let us substitute this area in the above expression. EMF E is equals to, if you take only the magnitude, no need to take that negative sign. This negative sign is in accordance with Lenz's law to find the direction of the induced EMF. So d by dt of B dot A, B and A dot product will be maximum since B and A are in the same direction. Aerial vector is acting along the direction of the magnetic field. So as the angle between these two is 0, we can get BA only. A is Lx. Here the magnetic field is constant, length is constant, only x is variable. So the EMF E is equals to BL dx by dt. The rate of change of position of this conductor with respect is called the velocity of that conductor. So the induced EMF will be BLV, which means that this conductor itself acting as a cell which is having some EMF. Every cell should have positive terminal and negative terminal. Now the polarity of the cell can be found by using Fleming's right hand rule. According to the Fleming's right hand rule, stretch the first three fingers of your right hand in such a way that they are mutually perpendicular to each other, and the forefinger should represent the direction of the magnetic field. Thumb represents the direction of velocity, so that central finger represents the direction of the current. Here in this, the direction of magnetic field is showing by the forefinger and the thumb is along the direction of velocity. So the central finger is pointing upwards, which means that current may flow in this direction. Which means that if you replace the entire conductor with a cell having the positive terminal upwards, this is the positive terminal and this is negative terminal, it acts as a cell having the EMF E is equals to BLV.